Hello, it's John Cheek here from UniTasterDays, and today we're going to look at university courses in data science. You can see on the screen now is our checklist of the areas we're going to talk about. But ultimately, it comes down to why you might want to consider studying data science, what to expect if you do study it, a few application tips and careers you might want to go on to in the future. I'm delighted to be joined by Professor Clough, joining us from the University of Sheffield. He is our expert. He's going to cover all these areas, as well as things like how data science will impact you, even when it comes to watching Netflix. And with that, Paul, I'll pass things over to you.
That's great, John. Thank you very much. Hi, everybody. My name's Paul Clough, and I'm going to talk to you today about data science. But I thought before talking about data science, I better just introduce myself and tell you a little bit about who I am. I've had a bit of a sort of potted work history. I left school at 16, worked as an apprentice at BT at Marksham Heath at Dasport Park, which is their kind of technology centre, where I was mainly doing kind of electronics and software engineering. But then in 2001, I joined the Department of Computer Science at the University of Sheffield, where I was doing a research project together with a part-time PhD as well. I then joined the iSchool, which is the information school also at the University of Sheffield, a little bit later after doing that, where I carried on doing various research projects, but then also joined as a member of staff as well, an academic member of staff. My current role in the information school is Professor in Search and Analytics. Alongside that, though, so I currently have two jobs. So I work part-time at the University of Sheffield, teaching students and doing research, but I also have another job. In 2018, I joined a company called Peak Indicators, who are a Chesterfield-based data and analytics company, and I joined them to help kind of develop their data science capability. And so my current role in Peak Indicators is Head of Data Science and AI. Just to say that Peak Indicators have just been bought out by a company called TPX Impact. So that will be the name that we're going to be using going forward. So I think I've got a fairly, I guess, slightly unique view on data science in the sense of I've seen it from teaching data science, but I'm also seeing it from the actually doing data science and from the practice view. So before we talk about kind of courses in data science and so on, I guess we should just talk a little bit about what data science actually is and what it means. So I've got one definition which I've presented to you here. Data science is the science and art of acquiring knowledge and insight from all kinds of data. So just to highlight a couple of things about that definition. Data science, by its name, is a science. So it's a kind of a scientific endeavour. But a lot of doing data science in practice is a bit of an art as well, and something that you gain through experience. The kind of goal of data science, one of the goals, is to acquire knowledge and insight. And we might use that for things like supporting decision making, perhaps developing and building new products, services, maybe even understanding the world around us, so deepening our understanding. And I guess a key thing with data science that perhaps distinguishes a little bit from areas like statistics or traditional statistics would be the kind of applying analytical techniques to all kinds of data. So by that, I mean kind of maybe more numeric type of data that you might find in a sort of a spreadsheet, but can also involve analysing images, video, audio files as well, also with the purpose of acquiring knowledge and gaining insight. Data science as a field of study is a combination. It's kind of very interdisciplinary type of topic or field, and it combines areas such as statistical and scientific methods, data visualization. Nowadays, it's involving kind of AI, artificial intelligence, machine learning, together with areas like data analytics and more as well. Data science typically draws on those different fields. Increasingly, we're also seeing that people are taking the context of use into account as well. And that's to ensure that the data, algorithms, AI that you're using within data science, we're using them responsibly as well. I've put a warning here just to say that there are lots of definitions of data science. I've just given you one here. And part of the challenge about kind of data science as a field is that it's viewed differently from different perspectives and different viewpoints. But overall, I would say the general goal of data science is, again, acquiring knowledge and insight. How might we do that? Well, we typically follow a workflow or a process that looks a little bit like this. And again, these will vary, but often we have a problem that we're trying to tackle or solve, which can be generated by the business. Maybe it's a scientific question, research question that we're trying to solve, and so on. We then typically have to collect some data to try and address and tackle that problem. And a key stage in the kind of data science workflow is this idea of kind of exploring the data, this kind of playing around with the data. And we have to do that because often we need to gain a deeper understanding of the data. We may also then have to go back after doing that to collect more data, and we might do that a few times before we get the data that we need to then start doing our analysis. Analysing the data may also involve things like modelling. We might use statistical techniques, we might use machine learning, we might use AI, data mining and so on to analyse and model the data. That would be generally used to then try and extract knowledge and identify some insights and so on. But it doesn't just stop there. What we normally need to do is then start communicating our results and our findings. So a key, if you like, element of data science, a key aspect is that whole idea of communicating your findings. One of the other things we might also do is, as well as communicate findings, we may build data products as well. And typically this process, you don't just go around it once, you'll go around it again and again and again in a very iterative way as you kind of develop products, insight and so on. Just to give you a very quick example of how that might work in practice, this is a man called John Snow. He was around in the early 19th century, and he's very famous for, he was a physician, and he was studying cholera. And at the time, it was thought that cholera was an airborne disease, but he was kind of convinced from various ideas and studies that it was waterborne. And so he went around following that kind of data science life cycle that we've just seen, where he collected data. And the data that he collected was the deaths based upon cholera from different households. But John Snow very much acted like a modern day data scientist. He then started to analyze that data. So he collected the data, he might have cleaned it a little bit and so on and transformed it. And then as part of his analysis, what he did was to plot that data and put the data onto a map. Now, by overlaying the data on a map, what became suddenly apparent was that the deaths were generally located around a cluster. In this case, they were clustered around this particular X, and this X represents, it was a water pump on Broad Street. And so do these other X's as well. But what John Snow then realised was that actually it was likely that the source of the cholera was due to this particular water pump. So what he did is he shut it down, he removed the handle, and that stopped the spread of cholera, and in fact saved many people's lives. And I think this is a brilliant example of data science where not only did John Snow gain insight, but there was real impact and action based upon what he did. And he changed the scientific thinking, and he saved many lives as well. And that can be true of doing data science today. Data science, though, as a term, John Snow wouldn't have called himself a data scientist, and many people years ago themselves wouldn't have called themselves data scientists, even though they were probably doing data science activities. So this is a Google Trends plot where I've just pulled out some kind of key terms. So data science, big data, data analysis, and data scientist. And we can see that there's things like data analysis has had a fairly steady kind of uptake, people searching for the term data analysis or related to that. But we can see from probably around 2010, this blue line here, a lot more people were searching for data science. And that is probably sort of corresponds with our thinking that around 2010 was probably a term data science was starting to kind of be used. But data science itself is not a modern concept by any means, as the example of John Snow shows us. In fact, for centuries, people have been identifying patterns using data to derive insight and derive knowledge. So data science itself is building upon many centuries, decades of prior work. And we've seen on this is a really good report from the Royal Society. You can see some of the kind of key areas where these have kind of shaped and formed data science as a discipline, in this case, since the 1940s. But today, data science seems to be everywhere. AI is everywhere and so on. So what is it that's changed that has now kind of brought data science into our minds and even formed careers for people? Well, I think part of it is to do with the revolution that we're under at the moment. And the revolution that we're in is a kind of an AI and data revolution. Some people have called this the kind of, if you like, the fourth industrial revolution, where in this revolution, it's all about data, big data, connectivity, sensors, Internet of Things, AI, machine learning, excuse me, and so on. And all of these things are now changing the world in which we live. They're having an impact on business, on our lives, on society as well. And this is the kind of world in which we're now surrounded by data, and data is being used for all kinds of different things. I think one of the other big changes that we've seen is the rise of technology, data, but also the rise of machine learning as well, and AI. Some people claim that AI, machine learning, is perhaps one of the most important technologies of our age, of our era, and it really is finding its way into everywhere, into business and all areas of our lives. And as a data scientist, you're going to make a lot of use of machine learning techniques. Techniques that can, for example, learn to map between inputs and outputs, could be used to learn themselves kind of groupings within data and patterns and so on. And machine learning is really important because often we're presented with data sets that would be far too big for us to try and analyze in any other way. So we need the help of algorithms and we need the help of machines that can learn. So what can data science do? Well, I've listed a few things I think that data science can certainly help us with. So data science can help us to describe the current state of things. So you might have a dashboard within a business, and that dashboard is, for example, showing how many things you've sold over time. It's showing you, the state of the current state of things, or the state of play now. We could also use data science to detect unusual or abnormal events. We could use data science to help us to identify new insights or new patterns. We could use data science to help us diagnose the cause of events. We might use data science to help identify inequalities and biases, perhaps in decisions that are made by people or data sets that we have. And probably perhaps the most common use, and the one I've seen perhaps more of, is the use of data science to predict future events or activity. So if you're a business, if you're a shop, for example, you might want to use data science and historical data to try and predict or forecast how many things might you be selling in the next quarter. We often think about data and analytics and data science as a part of a kind of maturity, if you like, as a model or cycle. And this little cartoon here is meant to show, if you like, the different levels that you could have of analytics and sort of maturing and over time. So, we've got the descriptive analytics, which is just a sort of, state of play. How many things do I sell today? Diagnostic, which is that trying to identify maybe cause of events. So how does weather affect sales in this case? Predictive, what am I likely to sell next weekend? And then also prescriptive as well. How could I grow my business? And we're currently seeing the use of data science and in particular machine learning AI helping with areas such as predictive and prescriptive analytics, which are key to many businesses and organizations. Let me just give you just a couple of examples of how data science could be used by businesses. So here's one example where data science is powering and transforming Netflix. And data science is being used for areas such as providing users with personalized film and TV show recommendations. It's being used to predict in advance the popularity of content. So can Netflix are able to predict how the audience, how we might respond to a certain film or a certain kind of show. Netflix using data science for things like personalizing marketing content and the whole kind of user experience that people have. Also being used data science for optimizing production planning. And, data science is also being used for kind of, general technical and business decision making as well. But it's not only the likes of big organisations like Netflix that are using data science and data in that kind of way. Data science and analytics is also now being used quite a lot in local government as well. So here's some examples where you see all kinds of different sources of data, some of them very complex data, being then transformed and cleaned, and then a number of different tools, many of them kind of machine learning, being used to then provide all kinds of different services and all kinds of different insights. Often in local government, data analytics, data science is being used to help decision makers and policy makers. But you can see there's a whole range of other ways that data could be used as well to help citizens and to help the local authorities as an organisation themselves. We've also seen a lot of data science being used, for example, in social good. So here's an example from the UN where big data and AI is being used in all sorts of different ways, in all sorts of different projects to help people. And that's a really, really important use of AI, not just the big businesses, but trying to help everybody around the globe. And then what about COVID-19, the pandemic? What was the role of data science during the pandemic? Well, there have been various reports, there's been various articles written about how data science was used to help and to really transform our response to COVID-19. For example, in this report, it talks about data science being used to predict trends and hotspots, trying to predict kind of where COVID-19 might move next, certain groups of people, various demographics of people. Also, data science was being used to identify people most at risk and then be able to kind of, sort of help people to design interventions. Data science is also being used to support life beyond the pandemic. So data science being used, for example, to identify if an office space is overpopulated, if there are too many people in that space, or if too many people are too close together. So again, data science being used in every area of our life. So then you're maybe interested in data science. Why would you want to study data science? Well, hopefully those examples that I've given you already will have excited you. But here are some other reasons why I think people like to want to study data science. I think there are multiple job and career opportunities available for people with data science skills. And because when you do a data science degree, you're going to be learning a whole load of different things, not just numeric skills and analytical skills, but also wider skills as well that could help you in all sorts of jobs in all areas of life. Data science itself will help you develop key data skills. And we know that those key data skills are now important for interacting with every aspect of life because all of us are engaged within this data revolution. It's been recognised that there is a lack of data science talent and analytical talent. Many businesses, many organisations are struggling to find people with the right skills. Data science as well, it also gives you the know-how to tackle a range of real-world issues and problems. It also changes the way that you think about things, particularly around critical thinking. Also, I would say from my own experience that data science is enjoyable and it's also rewarding as well. So those are some of the reasons why you might want to study data science. But what are some of the skills that you need then for doing data science? Well, again, there are lots and lots of kind of frameworks and lots of views on the types of skills that you might need. And to be fair, I think it varies on the type of job that you end up having. But here are just an example set of skills that I think are fairly generic across the board. So as a data scientist, you're certainly going to need things like communication, teamwork, project management skills. It's likely you'll be working in a specific domain, so you're going to need to develop some domain expertise. Now, those are the sorts of things that you might not necessarily be able to learn in a university degree. Those are maybe the things that you will learn when you're doing the job itself in practice. Data scientists need to understand things like ethics and regulation, and there's been a real push, certainly recently, on ideas such as responsible AI. One of the things that you'll spend your time doing most as a data scientist is acquiring data, getting data, but also what we might call wrangling data as well. So that is trying to transform the data, clean up the data to be able to get it into a shape where you can then start doing your analytics and your modeling. You may be working with large kind of data sets, so you might need access and understand and know about what we call high performance computing, or HPC. An area of data science that's super important is this idea of being able to communicate those insights to people. So you'll be developing also not only analytical machine learning skills, but you're also going to be developing data visualization skills. Data science is founded upon topics also such as statistics and probability. So even though you might not necessarily dive really deep into some of those areas in certain courses, a basic understanding will be important to you. And then increasingly getting familiar with using and understanding machine learning is a key skill for data science as well. What about some of the tools that you might be using as well for data science? Well, there are loads of them, and I've just listed a few of them here. And on many data science programs, degrees that you'll do, you'll be experiencing the use of some of them. Probably not all of the tools, but certainly some of them. You'll also be exposed to various machine learning techniques, and I've given some of them here. But not only machine learning techniques, you'll also be exposed to other analytics techniques as well. Again, not necessarily all of these, and certain ones of these will be appropriate for certain types of problems and certain types of use cases. But certainly doing a data science degree is going to expose you to lots of different skills, lots of different tools and technologies as well. The other thing that's important nowadays is also to recognise some of the other issues as well. So particularly ethical issues around the use of data analytics and AI. So there's been a recent a real push and a real sort of need to understand, for example, that algorithms, AI, can exhibit real world biases. For example, it's been shown that predictive policing algorithms are racist, and there have been calls for them to be dismantled. As a data scientist, we really need to understand this, and we really need to understand the impact of the tools and technologies and the data science that we're using and building. There's been plenty of other examples as well. So this is a New Scientist article that talked around 5 different times that AI showed prejudice. And it's leading us to really think about data ethics and responsible AI. And that's becoming a key part now, actually, of many data science programs. I really like this. Somebody shared this with me the other day, and this is something called data hazards. And again, it highlights some of the things that data scientists nowadays also have to be thinking about. So things like the sustainability and the environmental cost. If you're running machine learning on big clusters of machine, or you're running, like, for example, deep learning methods that are very compute heavy, that has an impact on the environment. And there's more and more calls now on not just the businesses, but individuals as well, to be thinking about sustainability. Also in the data hazards, there are aspects or hazards such as automated decision-making and the extent to which that should be allowed. There's the biases that I mentioned before, the danger of misuse, privacy issues, lack of informed consent, and so on, and the list goes on. And the quote from Jurassic Park kind of summarizes some of this, that, even though we can do things, doesn't necessarily mean that we should. And that's really important to have that understanding, that view as a data scientist, because you really can affect and impact people's lives with the work that you do. Just to say that there are many other skills that are really important as well. So this was from the World Economic Forum's report, The Future of Jobs 2020. And this predicted, the top 10 skills for 2025, which include things like analytical thinking, innovation, active learning, so being able to learn yourself in your own time, perhaps, problem solving, critical thinking, creativity, and so on. So as a data scientist, not only do you need the kind of numeric skills, the analytical skills, maybe the kind of computing skills, you will also need some of these skills as well to engage with the workforce of today and tomorrow. So you might be thinking then, well, okay, what course should I choose? You might have already had a look on the web, and there are lots and lots of different data science courses out there. And what you'll find is that different courses tend to be different based upon maybe where they're offered from, so the department that they're kind of hosted in. So you often see data science courses being offered by maths and statistics departments, maybe computing and computer science departments. Also data science and maybe analytics being offered by management and business schools, maybe in economics and politics departments, and also information science departments as well. And I guess, which particular course you choose will depend on your own interest. Are you more interested in the kind of, statistical view on data science? Are you interested in algorithms and AI? Maybe a computer science perspective is better for you. Are you interested in the relationship between technology, people, data, and exploring those issues as well as analyzing data? So maybe the information science view is the right one for you. So I think it partly depends upon what specific kind of perspective you want to have on data science. I guess the other thing is that some courses will have certain entry requirements or expect certain prior knowledge. So certainly the data science in a statistics department will require that you've already got an equivalent of A-level maths or statistics, for example. Other departments, other courses may not. The other thing that might sort of also sway your thinking is the availability of a placement or internship. Data science is an applied subject, I would say. And so it really helps to be able to demonstrate those skills and practice those skills in a kind of an applied setting, which might be offered through a placement or internship. As you look around, you'll see that data science education is covered at all levels, ranging from undergraduate to MSc and onto PhD level as well. And so that might be something that you want to think about as well, whether you'd like to choose, a course that enables you and equips you to go on to gain perhaps further education. Let me just give you an example of, here's a course that we've designed at Sheffield in the Information School. This is our new BSc Data Science that's going to be launched in 2023 and 2024. And I wanted to give you this just as an example. I'm not trying to sort of sell you the course, but I wanted to give you a flavour for what you might study if you were doing this type of course. So the data science course that's offered by the Information School is not only focused on kind of the analytical side, it's very much thinking about the kind of wider societal and ethical areas as well. And you can see that's reflected in some of the modules that are offered. So in this case, you've got sets of modules in level 1, level 2. So those are years 1 and years 2. These are ones that you would have to take. And you can see that you've got things like in level 1, basically the foundations, what is data science, the kind of context in which data science works. You've then got some courses around programming. So in this case, programming for data science, which may be Python, maybe R, and so on. The key part of data science is data modeling and storage, being able to kind of interact with databases, being able to store the data in databases and so on. But as I mentioned before, data visualization communication is super important as well. So there's a whole module here on communicating data. Understanding how organizations can make use of data to become data-driven is the focus of another module here we see in level 1, as well as that kind of core statistical module as well, giving you that kind of the basic statistical insights that you need for doing data science. So that's not going to cover very deeply the whole of statistics. It's just selected aspects that you would need if you're trying to apply them to doing a data science task. You can see then in level 2, things move on a little bit to start talking about things like ethical data management and governance, what I might call stewardship. Then you've also got a follow-on practical kind of programming course, as well as then starting to explore areas such as AI and machine learning, in this case for advanced analytics. Key also is starting to kind of practice those skills and demonstrate those skills. So you can see in level 2, level 3 here, there are some labs that you would be doing as well. So those would be things like perhaps larger exercises, tasks that you might be set to sort of take you through that whole data science workflow or life cycle. You can also see in level 3 as well as the idea of a kind of a project or building that portfolio, which again is really important to be thinking about what you're going to be able to show prospective employees. So that hopefully gives you a bit of a flavour for, in this case, more of a kind of social science, information school perspective on data science. And it's well worth having a look at other courses as well. And you'll start to see that they definitely share some commonalities, like statistics, probability, and so on, but some will emphasise more on some aspects than others. How are you going to learn doing data science? Well, generally, it's going to be through a whole range of different kind of teaching methods. So that might include things like practical sessions, so lab practicals, might include things like lectures, seminars, and workshops. Often there's going to be things like self-study tasks for you to undertake. And I would say that often you tend to see that on data science courses, there is a bit of a focus on inquiry and problem-based learning, partly because that's one of the best ways of actually kind of learning data science and analytics, learning by doing. I've given you some examples here of maybe the types of tools that you might use. The one at the top here is an open source tool called Nine. It's a no-code resource, but enables you to build workflows for doing things like analytics, machine learning, and so on. The one down here is a Python notebook. Again, that's in this case a little bit different. In this one, based upon what you learn about programming, you'll start to kind of use these types of kind of tools that are used by data science in practice as well. Okay, what about data science jobs and careers then? This site is really helpful. This is the Prospect site, and they have a profile for a data scientist. And it's really helpful just to kind of reflect and have a look at the types of if you like, responsibilities, qualifications that they talk about in terms of a data scientist. One of the things I would emphasize is, although you can follow data science as a career, and many people do, I would say that doing a data science degree also equips you really well pretty much for any job, because most jobs nowadays, and certainly they're likely to in the future, are going to involve working with and using data. So the skills that you learn really would be transferable, I think, in many situations and scenarios. But just sort of focusing on thinking about kind of data specific jobs, here's the types of jobs that you could end up doing with a kind of a data flavor attached to them. So of course, there's kind of data scientists, advanced analysts. Those are the types of jobs that would lend themselves well to the types of skills that you might pick up on a data science course. But actually, you might be happy doing a data analyst role as well, or a data systems developer role. It might partly be based upon maybe past experience that you've got, the interests that you have, and the type of work that you want to do. But certainly doing a data science degree would equip you to do many of these roles. If you'd like to know a little bit more about, well, what does a data scientist actually do? There's a useful video produced on Coursera by IBM, which has a number of interviews and goes through the day in a life of a data scientist with a number of people. And that would give you can watch that for free, and that gives you a bit of a flavour maybe for what a data scientist would do in practice. If you'd like to see an example of more kind of what career progression might look like as a data scientist, I really recommend having a look at the government career framework there, government analyst framework. In fact, the government jobs might be an area that you're interested in working in, either central government, local government, and so on. But the government framework is very good. It kind of lays out, if you like, the different pathways that you could have as a data scientist, the types of skills that you need, the type of jobs that you'd be doing, and so on. And you can see here that the kind of progression goes from, very much the junior trainee data scientist all the way up to kind of head of data science and then further leadership roles as well. And these arrows going in and out kind of highlight that you could transfer some of those skills across to maybe other areas as well. But this is a sort of typical progression that you might expect, going from your kind of junior data scientist very much straight out of kind of maybe sort of a degree where you're keen to kind of apply what you've learned, and you're going to be building up that experience over time, developing your skills, and to the point where you might even become yourself a head of data science with leadership responsibilities. Just to give you a bit of a flavour for what I do as a data scientist, I've had a variety of roles, if you like. Some of it has been around thinking about sort of helping plan the strategy and the capabilities for data science in Peak, in the company that I work for. Other things have involved things like helping with marketing and sales activities. But I've also done quite a lot of hands-on data science work as well. A lot of that has been building predictive models. So I've built some models to predict customer churn, built some models for forecasting sales, and so on. And a lot of the work has been thinking about how you actually build those models in the systems, in the tools that the customer is able to work with. One of the other things I spent quite a bit of time doing is learning cloud-based technologies for AI and machine learning. And again, that's a really key area, I think, for you guys to get into in the future, because that's going to be how things are going. So that is making use of cloud-based technologies. So those are sort of some of the things that I've done myself and that you might end up doing yourself. Okay, you're interested. What should you do next? Well, I think here's a few things that I'd think about. I'd maybe think about finding out a little bit more about data science and whether it interests and excites you. So, for example, there's a free course run by DataCamp called Data Science for Everyone. Why not watch some of those videos and get a feel for, is that something that would excite me and interest me? You might want to actually play yourself with some data sets and see whether you like getting your hands dirty. Well, one way of doing that would be to sign up for a Kaggle account where you can have access to compute power, a notebook. It's a cloud-based infrastructure you can use for doing data science, machine learning, and so on. But there's plenty of data sets and tasks that you could have a go at as well. And that might be a great way of building up your portfolio. And that would be something that you could also write on a kind of an application covering letter as well. You might also want to explore what courses are available, the kind of topics covered, to kind of get a feel for what's the kind of right course for you. What's the right kind of department that you want to maybe pursue data science within. The other thing I'd probably say is look at some example data science jobs, for example, on LinkedIn, to see could you actually see yourself doing that kind of job? Is that going to be the sort of thing that would really satisfy you and make your career enjoyable for you? Just to also say, a lot of people often worry about, do I have the kind of enough mathematical skill to be doing data science? There are plenty of data science roles that don't require deep mathematical knowledge or skills or statistical skills. It's certainly going to help, and in some courses it's a requirement. However, in many tasks that I do on a day-to-day basis, just a working knowledge of stats and so on is more than adequate. So do not let that put you off by any means. I'd certainly say that you need to be, numerate, and you also need to really enjoy playing with data, because you're going to spend a lot of time messing about with data. And that's it from me. So I hope that's been helpful for you, and I wish you all the best in your future data science careers.